All right, today let's work out some of the questions from your 10.3 exponential growth model paper. We're going to do the highlighted questions, number 1, number 6, number 7, and down here, number 8. Make sure to have your equations and your formulas handy. We're going to use those as we help go through some of these questions. Let's start with number 1. Feel free to fast forward at any point in the video if you feel like you know what you're doing and know what the next step is. The number of flowers in a botanical garden grow by 15% each year for the next 15 years. The original number of flowers is 125. And how many flowers are there predicted to be in 10 years? So this is an exponential growth problem. So you're going to take your p's of 0, which in this case is 125, because that's what you start with. So do 125 times, since it says it grows, then it's going to be an exponential growth. So I'm going to do 1 plus my decimal number. So 15%, if I change 15% to a decimal, I can simply take the decimal point, move it 2 times to the left. I can also take 15 and divide it by 100. So 1 plus 0.15 is the same as 1.15. My exponent is the number of years, or time in this case, and it says it's going to do this for the next 15 years. But the question says, I want to make a prediction for the next 10 years. So really, I don't really care that this equation works for 15 years, because all I wanted to figure out is what is it going to be in 10 years. So do 125 times 1.15 raised to the 10th power. I get about 505.69. Since this question is about flowers, you can't have part of a flower. Either you have a flower or you don't. I'll say that this number instead will just go to about 506 flowers. Let's go to number 7. Excuse me, number 6. So in this case, I'm trying to figure out what p's of 5 is. So I need to now work backwards. I know what p's of 8 is, I know what p's of 9 is, but I need to go backwards. As you see, the sequence is getting bigger as I go from p's of 8 to p's of 9. It goes from 18 to 72. But I need to go backwards to figure out what p's of 5 is going to be. First of all, I need to figure out what my rate is going to be. I don't know what my common ratio is going to be. So to figure out a common ratio, I'm going to take my 9th number, which is 72, and divide by the one before it, which is 18. Because I don't know what 18 times what gives me 72. When I divide, I get 4. That tells me that 18 times 4 gives me 72. So my common ratio is 72. So what I want to do is I want to plug in, instead of p's of 0, let's plug in the number I know, which in this case is p's of 8. So that means that 18 is a number I know, times my common ratio, which is 4, raised to the power of the number I'm looking for. So in this case, if I know p's of 8, but I'm trying to find p's of 5, this is the opposite of what I did in number 1. Number 1, I counted forward 10 years. This one, I'm counting backwards 3 years, because 8 minus 5 is 3. So if I count backwards by 3, I simply want to put an exponent of negative 3. And then I type in my calculator, 18 times 4 raised to the negative 3rd power. So about 0.28. So I'll round that to about 0.28. Let's go to number 7. Number 7 gets the compound interest problems. How much interest would you earn on an account with a 20% annual interest rate compounded daily that you initially invested $100 into for 1 year? So I'm going to start by using my number of 100. There's my principal. That's how much money I initially invest. In parentheses, it's 1 plus my rate. My rate is 20%, but when I change it to a decimal, it turns into 0.20. Divided by n. N stands for the number of times compounded annually. It says compounded daily. So daily, How many days are there in a year? There are 365 days in a year. That number also goes in my exponent, which is the first number, times the number of years. And my years in this case, it says right here, is 1 year. You can type this in your calculator or in Desmos, either way. Let's see what number we get. Be careful when you type it in your calculator, though, because a lot of people make the mistake of typing it all in at one time. What I first want to do, step one, is figure out, like we said in our formulas, is to figure out what the exponent is. 365 times 1 is just 365. So I can type the rest of this in at one time. 100 times 1 plus 0.20 divided by 365, close my parentheses, raised to the power of 365. We get 122.13. And since we're talking about money, I'll round in the hundreds place. So about 122.13. Normally I would stop there, except the question says, how much interest would I earn? Interest means how much extra did I make? How much money did my money make? So I invested $100 of my own money into the account. So if I take out how much money that I invested that $100. I'll even write next to that. That's my principal. When I take out the $100 principal that I initially put in myself, then I get an answer of $22.13. But just think, if I'd invested, instead of $100, if I'd invested $1,000, then that $20 might turn into $200 or $300. The more money you invest, the more money you make. Let your money make money. Let's go to number 8. Here's our last one. So this type of question is one you'll see common in banks. So this could be any generic bank, BB&T, Ally, Wachovia, or Wells Fargo. Any bank that you see is going to tell you that their interest rate is the best because they want to make your money and they want to make money off of your account. So they don't want to tell you to go to another place. Account number 1 would say, hey, you get a higher interest rate with us, so you should invest with us. Account number 2, bank number 2 would say, hey, you want to invest with us because you can invest more with us. But their goal is to make money. And they want to make money off of your money, so be careful in who you invest with. So let's do the math and see which one is a better investment for Martha. Marcia, I'll do number 1 up here. So here is account number 1. Here's her options for number 1. So the key here, again, is compound. The word compound is in there, then use your compound interest formula. So the initial amount that she invests is right here, $4,500. Times 1 plus the principal. And then my percentage is 20%, so that's 0.20. It says compounded quarterly. Think of how many quarters there are in a dollar, how many quarters there are in a year. There are 4 quarters in a year. That 4 also goes up here. It says I'm going to invest the money for 5 years in both accounts. That's 4 times 5. Again, know what your exponent is first. 4 times 5 is 20. I type the rest in my calculator, so 4,500 times 1 plus 0.20 divided by 4, raised to the 4 times 5, which is 20th power. Be careful how you type this in. So your right answer is this number here. However, if you were to type in 4 times 5 as your exponent, instead, you get this number, which is not your right answer. Because what the calculator does is does all of this first and then takes your answer using PEMDAS and then multiplies it by 5. It takes this answer, multiplies it by 5 when you're done. So be careful on how you type that in. So again, the right way to do it is to raise it to the simplified exponent form, which is 4 times 5 is 20. So get this number here. I'll round this to the hundredths place because we're talking about money. So account number 1, she's going to have $11,939 and about 84 cents. Account number 2. So she invests $6,000. She's investing more money times 1 plus. Her rate is now 15%, so a less interest rate. It is compounded monthly. How many months are there in a year? There's 12. The 12 also goes in your exponent. Times the number of years, again, it's for 5 years. Know what 12 times 5 is? 12 times 5 is 60. So let's type everything in at one time. So 6,000 times 1 plus your rate divided by the number of times compounded annually, raised to the 12 times 5, which is 60th power. I get more money, $12,643 and about 9 cents. We'll write that number down here. So on first glance, it says which option gives her the most interest. So it looks like option 2 is the way to go. She has more money. But again, she invested more money in option number 2. So it's not really a fair comparison because it's kind of like saying if I invest $1 billion versus I invest $1, I'm obviously going to have more money if I invest $1 billion instead of $1 because the interest is going to be more. So what I want to do is look at a fair account. I want to subtract out how much money I invested. How much money did I initially put into each account? Well, the first one, I put in $4,500, or Marcia did. For the second one, I'm also going to subtract out my principal. I'll even write the word principal up here. So when she subtracts out the principal, that means that how much money does she have left over? Excuse me, she invested $6,000 in that second one. So how much money does she have left over? So when I take that first number of $11,939.84 and I subtract out the principal of $4,500, I get an answer of $7,439.84. Account number 2, I get $6,643.09. So in other words, she made about $7,000 on account 1. She made about $6,000 in account 2. So if she's looking at the one that gives her the best way to go, it would obviously be account number 1. Even though she invests less money because of her higher interest rate, then she was able to make more money in the end. She made $7,000 versus $6,000, a difference of about $800 between those two numbers right there. Again, the bank won't tell you that. They're going to tell you that if you go with them, you would make $7,000. They're not going to tell you that you could make more or less money with another company. So be very careful on how you invest your money and make sure you invest with somebody that you trust. So the right answer for this one will be account number 1. Number 8 is just like number 10 when you get down to it. And number 9 is very similar to number 7. I hope that's helpful.